In this series, I will focus on modern C++, which refers to a form of C++ programming which emerged out after the introduction of a new C++ standard called C++11 in 2011, and this form of programming is still continuing to evolve. Specifically in this recording, I will talk about rvalue expression and rvalue reference, which is linked to the move semantics for a class, which I will talk in the next recordings. I have this code to begin with. First, let me talk about rvalue expression. This is an expression which does not represent a variable which or object which lasts for a long time. This is generally a temporary a variable expression that is exists temporarily, or which is available to be used by the program only temporarily. This kind of expression is rvalue expression. In contrast, the lvalue expression is a variable. Usually you may define like this and use this variable throughout the program, lifetime of the program, or throughout the up to the before you actually return control returns back to the operating system. This variable occupies memory space. It contains the data in the memory space. It is usable. So this kind of expression is called lvalue expression. This lvalue expression can be placed on the left hand side of an expression. For example, x assignment, left hand side of an assignment. You can do something like this, x equals to 5, right? So but when we talk about rvalue expression, it is something that you cannot place on the left side. For example, all the literals, for example, we have integer literal 25. This is integer literal, and we have double literal, and we may have character literal, or we may also have string literal. All these are rvalue expressions. You cannot place these things on the left side in the assignment. You can have 25 equals 36. This is 35. This is not allowed. 22.522 equals to 23.33. This is not allowed. A equals to, this is not allowed, and also something else. Let's say this kind of assignment is not allowed. You cannot place the rvalue expression on the left side. So you can only place this on the right side. For example, into y equals to 25, and so on. Let me comment this out. Sometimes the result of an expression can also be lvalue, rvalue. For example, if I do pre-increment plus y, this result is lvalue. Therefore, you can place on the left side of assignment, right? So if I want to see what happens after this expression or this operation, y, and I want to see the value after that, and I want to make sure that this does not actually complain the syntactic error. Let me go to the terminal to run this program. So this is a warning. I'm going to be ignoring this and run it. So we have first it was 25, and after that it was 45. So what happened here is this incremented, but this y is the result is the lvalue expression as a y, then 45 is copied to y, and then after it became 45. but you cannot do something like this. For example, y plus plus. This is this expression returns r value expression. So you cannot copy data into this expression. So this operation results in L value expression. You can place on the left hand side. This operation results in R value expression. You cannot place on the left hand side. If I compile this, compiler will definitely complain. So it is complaining this as an error. Y plus plus equals to 35. So you must place this R value expression on the right side of the expression. For example, int z equals to y plus plus. You can do something like this. And also we have the variable x over here, x equals to 5. And if I have an expression like this, plus x or minus x, these also results into R value expression. So we cannot place on the left hand side. This assignment, this is not allowed. So only you can use the result of the expression. You cannot write data into it. Similarly, some objects that would be created if you have user defined type. And if you create an object of such a type and pass the data, so this creates an object and copies data, but the result of this expression, entire expression, is R value expression. So you cannot place this on the left hand side. This is not allowed, right? So you can place it on the right hand side. For example, something like this. You can do this, but you cannot place this on the left hand side. Now, having talked about this L value and R value, let me talk about the reference. So you might have learned about the reference in basic C++ course. If I want to create a reference is basically alias for a variable or an object, right? If I want to create alias of this student object, I would do something like this. Or if I want to create a reference to refer to this variable x, then I would do something like this. Sorry, I should have used this character ampersand here, int ampersand, and ir equals to x. So this is the reference. This sort of reference is called L value reference, because you can this reference actually refers to the L value expression, which you can place on the left hand side. You can do something like this, ir equals to 45 or so on. But what about, for example, if I want to have a reference, let me first make sure that this compiles. I don't have issue with this code, then I would go ahead and discuss that. So I want to make sure that I don't have any compilation error. I think I should have removed this expressions. Let me go back to the code. This not allowed expression I want to avoid. Try again. So I think I might have missed a semicolon before that statement. Yeah, I missed a semicolon here. I didn't have error. These are the warnings because I have not. I don't have an expression to use this. The data I mean variables that are created. Now, for example, if I want to have something to refer to this r value expression plus x, I cannot use L value reference x. Let me call this ir1 equals to. If I do this, this is r value expression, right? So if I have this is a L value reference. So if I try to use the L value reference to refer to the r value expression, it will compiler will not let me complete the compilation of that code. So it is already complaining. You cannot bind a non-constant L value reference of this to an r value of type integer. So if you want to have a reference to r value, then you need to have something called r value reference, and you can create that reference by using this syntax double ampersand ir1 equals to plus x. Let me comment this out. So after that we should be able to use this r value reference to refer to the data ir1. So we can go ahead and see whether this actually works or not. So it's not complaining, and we have this ir1. This was the data was set to 45, so we are actually having r value reference referring to the a different data. This is not the same data, it's a different data. I mean the value is same, but the memory space where it is stored is different. Similarly, you can do something like this. Int reference xr equals to plus plus x, because this is L value reference. So this is I mean L value, the result of this evaluation, and then you can have L value reference to refer to this. And if you want to refer to x plus plus, then you can create r value reference int xrr. So we can have the cout statement to display this the data through these references. Let me call this xr and xrr. So let me see. I want to make sure I don't have any issue with this code. So we have this difference is because of this I think the plus plus operation. So 47 and 46 it is working. Now I actually want to talk about because this syntax will come up in the move semantics that I will talk in the next recording. Copy semantics, this syntax was used in copy semantics that I already have discussed in one of the previous recordings. So this is important, and also I would like to have two functions, stdref and stdmove. These are the function. This function actually is available in a library called this is available through this library. If you want to use this function, you need to include this library on the top. If you want to use this function, you want to include this library. So this function actually returns L value reference to a variable or object, and it returns R value reference to a variable So let me put this functions in action. Suppose I have I can do copying of this thing. Let me call this 1 and 1, and if I want to get a L value reference and use this variable to refer to that, then I can pass this variable inside this function, ref function, and then this function will return L value reference, and that is actually this will actually refer to that L value reference. And if I have this function move function, I put inside, and it will actually return R value reference. So I need this R value reference to refer to it. If you try to do otherwise, for example, use this to refer to the reference returned by this function, compiler will complain. So you can use this to refer to this result, and you cannot use this reference to refer to this result. So let us see the these things in output. XR1 and cout XR1. Yeah, the reason I'm getting this error is I have not included the library that I need to include on the top. So I need to include this library and this UTDT library. So now there's some typo error, I think STC and this thing. Go back to the code. So this is working. Now a final thing I want to talk here is you can use this L value R value reference to have a overloaded function. For example, instead of having this cout statement, if I want to have a function called let's say print and display this thing here. So you can pass you can make this function receive only L value reference by if this is XR is 1, then I want to make this function receive L value reference. Then we call this VAL. And I can overload this function and with a different parameter, which is instead of L value I want to have R value reference. So if the function, if let me just copy this and then I'll talk about that. Let me have a message here so that I can identify when this function is called and something is displayed. I can be sure that which function is actually called. L value and R value. So if a function same function is called with r value reference, then this function should be called. If this print function is called with l value reference as an argument, this function should be called. So let us see that thing here. If I call print function with let's say x, this is l value, and if I call print function with plus x, this is r value, and again I call print function by using this function x. So in this case I expect in this case the l value reference version of the print function should be called. In this case r value reference version of the print function should be called. In this case again l value reference version of the print function should be called. In this case r value reference of the version of the print function should be called. Let us see that. Now you can see this was first l value version of the function was called, then r value version of the function was called, l value version of the function was called after that, and r value function was called after that. So this actually behaved exactly in the way we actually expected it to behave. So this is all I have to talk about these topics. In the next video I will talk about move assignment semantics. Thank you for watching this video.